Great things come with great struggle and at a great price. The same was the case with the James Webb Space Telescope. NASA, along with ESA and the Canadian Space Agency, spent $10 billion. Seriously, $10 billion. Is the James Webb Telescope worth $10 billion? Well, to know the answer, you have to watch the video. Why did a $550 million project escalate to $10 billion within 22 years? The James Webb Space Telescope, the successor to Hubble, had faced many technical issues during its manufacturing and launching. As a result, Webb's launch date was delayed several more months than expected. Similarly, the project crossed its estimated budget of $550 million to $10 billion. You must be wondering, why did NASA spend so much public money on this project? And was it worth it? This video will explain how and why the James Webb Space Telescope went over budget. The James Webb Telescope true cost. The issue of over-budgeting. It's said that the James Webb Telescope wasn't supposed to be the most expensive space adventure in history. Back in 2000, the estimated cost of the telescope was $1 billion. In 2005, the estimated budget of the telescope quadrupled to $4.5 billion. The telescope was supposed to launch in 2010, but the main instruments of the telescope were delayed and not delivered to NASA. At that point, the estimated budget was $6.5 billion. But the price kept on rising as nearly every part of the telescope had to be invented. It required advanced skills, technologies, and specialized conditions. By the time of its launch at the end of 2021, the cost was around $10 billion, making it the most expensive space project in history. Before the telescope's launch, another big issue was keeping it safe from pirates. Well, the telescope was to be launched from a European spaceport, so NASA transported it from California to French Guiana, South America. It took 16 days for the telescope to reach its destination in South America through the Panama Canal under extensive surveillance by European agencies. The launch cost ESA and the Canadian Space Agency $1.1 billion. But all of this will be worth it when James Webb starts to reveal comprehensive details about the universe. The spending doesn't end here. NASA will spend another $850 million on the telescope in the next 5 years. Extending the life of the telescope requires more money. Timeline of the James Webb Telescope. In 1996, Next Generation Space Telescope was initiated. In 2002, NGST was named the James Webb Space Telescope. In 2003, $825 million prime contract was awarded to TRW. In 2011, James Webb Telescope was threatened with cancellation. Later, in 2014, the first combined test of all 4 instruments, including cryogenic testing, was conducted. In the same year, the U.S. funding hit $650 million. 2 years later, in 2016, cryogenic testing of instruments was completed, and in November, the same year, JWST construction was completed. The launch of the JWST was delayed to at least 2020 by the end of 2018. Due to impacts of COVID-19, the launch was further delayed to 2021. Finally, the telescope was launched on December 25, 2021. The telescope arrived in its final orbit on January 24, 2022. On July 12, James Webb Space Telescope released the full-color images revealing the age of the universe and details about exoplanets. The James Webb Space Telescope wasn't supposed to be one of the most expensive scientific projects in history. The estimated price proposed before starting the project was just $500 million. But the telescope's complexity and technical issues surprised NASA when it resulted in 10 times more costly than expected. Surprisingly, it's got so expensive that Congress nearly scrapped the project. So why did NASA continue to spend this much money, and why did it take so long to launch the project? Let's dive into the details to find the answer to our queries. Why is there so much talk about the James Webb Telescope? How is this different from other telescopes? Unlike the Hubble telescope, which revolves around the Earth, the James Webb Telescope revolves around the Sun instead. About 1.5 million kilometers away from the Earth, this telescope stays in the Earth's shadow at a point named L2. Its orbit is around the Sun. The James Webb Telescope reached its exact location L2 on January 24, 2022. Even after covering a distance of millions of miles, the telescope has enough fuel left to complete its mission. Fuel estimation versus fuel consumption. According to the initial fuel consumption estimation, it was believed that the telescope would remain in operation for almost 10 years. The recent estimates reveal that the telescope has a lot more fuel left. Thus, it will remain in operation for almost 20 years. How does James Webb work, and how is it different from the Hubble telescope? James Webb Telescope, also known as Webb, is a successor of the Hubble telescope. It will ascertain and provide more details about discoveries by the Hubble telescope. James Webb is a large space observatory that is optimized against infrared rays. Hubble was the first telescope to capture infrared and optical images. During its 25-year life cycle, it has revealed crucial information about the universe. Due to limited lifespan and focal length, Hubble had certain limitations. Therefore, scientists came up with the James Webb Telescope. It's a joint venture of NASA, ESA, and the Canadian Space Agency. The electromagnetic spectrum ranges from gamma rays to radio waves, with different wavelengths. Telescopes are designed to capture different rays in the electromagnetic spectrum so we can see things that can't be seen with the naked eye. The James Webb Telescope will observe the universe from the L2 point using infrared waves. It remains in extremely cold weather and captures cosmic rays emitted by heavenly bodies. It has a sensitivity range of 0.6 micrometers to 28 micrometers. That's why it can reveal shocking information about the first stars in the universe. James Webb is relatively huge in its structure. Whereas Hubble's mirror is just 2.4 meters in length, the length of the mirror fitted in the James Webb Telescope is 6.5 meters. Due to the large mirror size, it can detect faint signals from old stars and bodies. The mirror is plated with 24-karat gold because gold is one of the best light reflectors. Therefore, the mirror has 98% reflectiveness. Here's a problem. As I've already mentioned, everything that radiates infrared, heat waves come out of it. When a telescope works on its own, it will radiate some heat, and some infrared waves will come out of it. These rays will start interfering with the infrared rays coming from these galaxies. To address this issue, James Webb is being operated at -233 degrees Celsius. Can this temperature be maintained in space? Yes, it can be, as space temperature usually remains low. Unless sunlight interacts with an object, for example, on the moon, the temperature is usually -1,790 degrees Celsius. But as soon as sunlight interacts with its surface, the temperature may rise to 120 degrees due to the absence of an atmosphere. So, to stop the telescope's interaction with the sunlight, the telescope is covered with a special sun shield. This sun sheet can easily cover a whole tennis court and is in the shape of a kite. A very special material, Kapton, is used in its manufacturing. Many materials were tested to select the best one to block sunlight efficiently. The sun shield is covered with 5 layers of Kapton. Every layer is as thin as human hair, and there is a vacuum gap between each layer. Further, every layer is coated with aluminum, and the first 2 layers near the sun have a doped silicone coating too. The James Webb Telescope does not revolve around the Earth like the Hubble telescope. It revolves around the Sun approximately 1.5 million kilometers from the Earth. The telescope is deployed at the L2 point. L2 means Lagrange point 2. L2 point keeps revolving with the Earth. NASA said that constructing and deploying the telescope is so complicated that they identified almost 300 potential problems during its launch. 300 points of no return. One mistake, and the whole $10 billion project would be ruined. What the future holds for us. Pictures that were received on July 12, 2022 from the James Webb Telescope were made public. It revealed a lot about the beginning of the universe, the exoplanets, and details about life on other planets. According to space scientists, there are 3 million potential habitable planets in the universe. Previously, NASA had observed only 5,000 exoplanets in our Milky Way. In 2008, researchers had found from all the planets we have observed until then, there is one planet that is very similar to Earth. There are chances of life there, The name of the planet is TRAPPIST-1e. The exoplanet is only 40 light-years away from the Earth. 40 light-years, or 380 trillion kilometers. But in the context of space, this distance is not too far. The Sun around which the planet revolves is an ultra-cool dwarf star. This is relatively cooler than our Sun, so the temperature on this planet lies within the habitable zone. Further, the planet's dimensions are quite similar to that of Earth's. Its radius is 91% of the Earth's radius, and its total mass is 71% of the Earth's mass. Further, the planet has solid rocks. How does this planet relate to the James Webb Telescope? In the coming months, the mirror of the James Webb Telescope will be turned towards TRAPPIST-1e, so it will analyze the planet in detail. It will ascertain the presence of carbon dioxide, methane, and water vapors on the planet's atmosphere. If there is a certain combination of these gases on the planet, we can hope for the possibility of life on this planet. What will this telescope discover in the future? Can it find a planet with Earth-like conditions where life can be found? Only time will tell.